For pregnant women, current fetal monitoring devices are a cumbersome array of wires and tape that require constant adjustments and quite literally tether an expectant mother to a hospital bed. Now a team of researchers at Northwestern University have developed a suite of wireless devices that can do all that current monitors do, but at much less cost and without those constraints. Joining us now to talk about these new monitors is the leader of the research team, John Rogers, professor of materials science and engineering, biomedical engineering, and neurological surgery at Northwestern University. John, welcome back. So what were the challenges with current technology that led you to want to develop these new monitors?
Well, first of all, thanks for having me, and thanks for your interest in our work. I think you kind of outlined it pretty effectively. I mean, the current hospital standards for monitoring the health of the mother and the fetus and the neonate immediately after birth involve really kind of a rat's nest of wired-based sensors that mount at different locations of the body and terminate at bedside, level data acquisition electronics. And the birthing process and giving birth involves lots of motion, and those wires become severe constraints not only for the expecting mother but also for the healthcare professionals who are involved in the birth process. And so we wanted to get rid of all of that kind of hardware, old style hardware, and move to a purely wireless based platform to really liberate women from these kinds of cumbersome monitoring systems.
John, explain how these new monitors work and what makes them obviously superior to the ones that are currently being used.
Yeah, so they actually reproduce all of the measurements that are made typically, even in the most advanced hospital settings, but those measurements are accomplished with Band-Aid style devices. I mean, they're thin, they're soft, they're flexible, they're fully wireless. They mount at relevant parts of the anatomy, the chest of the mother, the belly, her finger, to really monitor all vital signs associated with the mother as well as the fetus. And they're all operating in a time-synchronized fashion, streaming data to just a conventional smartphone, thereby reducing the costs as well.
What kind of information can your monitors collect that wasn't previously being collected by the old-school wired monitors?
Well, we're doing everything that's been done in the past with these kind of old-style devices. So we're capturing uterine contractions, we're doing fetal blood oxygenation, we're doing temperature, heart rate, respiration rate of the mother, but we're also capturing continuous blood pressure. We're getting fetal heart rate, again, continuously. We're measuring the body orientation and the activity levels of the mother. We're capturing cardiac sounds as well as ECG measurements. And all of it's done with a higher level of fidelity as well as eliminating the wires. You eliminate that cumbersome tether, but you also eliminate a lot of the noise that's induced by the wires themselves. So the data fidelity is higher, and we're capturing a much broader suite of health-related parameters, both of the mother and the fetus.
How might these be useful? I would imagine, especially in rural areas or women who want to have home births, developing nations.
Yeah, well, one of the exciting things about this program and what we've just recently published is we were able to team with the Gates Foundation and the Save the Children organization to put these devices in lower and middle income countries. So we've monitored almost 500 women in Zambia during childbirth, straight through the intra, and postpartum periods. And that's very exciting because the cost structure allows these kinds of platforms to be inserted even in these highly resource-constrained, challenging areas of the globe where, quite frankly, they add the most value. And I think that's a very, very exciting part of what we're doing.
And you mentioned the Gates Foundation and Save the Children and working with them in development. Why is this something that those two organizations are interested in?
Well, they're interested in saving lives, in those sort of challenging parts of the globe. And if you think about mortality and you think about women, childbirth represents the most dangerous activity that they'll engage in their entire lives. And currently, there's really no monitoring technology at all in many parts of these countries. We're in Zambia, Kenya, and Ghana. And so the need is very strong. And being able to monitor and to intervene quickly if there are problems during childbirth can save lives, quite frankly.
What could it cost to develop these monitors and to deploy them once they are ready for prime time?
Yeah, so that's a very important question. I think the Gates Foundation, Save the Children organization, they're really only interested in technologies that have cost structures that enable their deployment in these parts of the world. And so you think about the cost per patient per day is the way you think about it. And because the devices are reusable, because they involve rechargeable batteries, because you can use a smartphone for the monitor, and smartphones already exist even in these parts of the world, you end up with cost estimates at full scale deployment volumes of a few cents per patient day is the way you think about it.
Wow. So what would the next step for these monitors be then, and when might we see them deployed in hospitals both here and abroad?
Yeah, so it's really all about the FDA approval process at this point, and so we're deep into that regulatory process. I think we're probably a couple of months out from getting our first approved indications for these devices, and that will be an exciting milestone for us. And that's really the trigger. That's the gating item in getting these devices out at scale. We've already put together a supply chain and a manufacturing flow, and we know how to scale up the production of these devices. But they're yielding vital signs information that's critical to patient care, and so that FDA approval process is very important, and we're in the latter stages of that.
Okay. Well, best of luck to you. We look forward to hearing more when you get there. Thanks, John Rogers.
Yeah, great. Thank you very much.